Hello everyone, my name is Tang Jin Song. I am from FST UKM. Today, I will present a study on the soil ecological experiments of polyethylene microplastics published in the journal Scientific Reports in 2024. The aging and fragmentation of agricultural landfills results in a large amount of PE microplastics. The amount of microplastics in agricultural soil is far greater than that in the ocean. Microplastics are difficult to degrade and easily absorb pollutants, which can be transferred along the food chain and pose threats to the ecology and human health. However, most existing studies only analyze a single variable such as concentration or particle size separately, lacking systematic research on the soil nutrients cycling and overall ecological functions under the combined effects of both variables. Therefore, the authors put forward three hypotheses. Microplastics alter the availability of soil nutrients. High concentration and small particle size microplastics are more harmful. Microplastics reduce the ecological functions related to soil nutrients cycling. The test soil was collected from the loess soil of the Yellow River floodplain without any plastic film contamination, which was highly representative. Two types of PE microplastics, 30 micrometers and 130 micrometers, were set up along with 5 concentration gradients of 0%, 1%, 3%, 6%, and 10%. The 1% and 3% concentration simulated the common pollution in farmlands, while the 6% and 10% concentrations precedented extreme heavy pollution. A total of 9 treatment groups were subjected to constant temperature cultivation for 30 days. The pH soluble carbon and nitrogen available phosphorus and potassium soil respiration and 3 key soil enzymes were measured, and the soil comprehensive function index was calculated. Statistical methods such as variance analysis, RDA, and random forest were used to analyze the data. The core results are divided into 3 parts, comparing the differences between the two particle sizes. First, soil chemical properties. 13 micrometers microplastics significantly reduce soluble organic carbon and available phosphorus and potassium, causing soil acidification. At high concentrations, the active phosphorus significantly decreases. 130 micrometers large particle only cause a significant loss of available nutrients at high concentrations and have low obvious effects on soluble carbon and active phosphorus. Second, soil biological indicators at 30 micrometers. It inhibits soil respiration and enzymes related to the carbon cycle, with only the urease activity increasing. At 130 micrometers, it instead promotes soil respiration and the activity of carbon-related enzymes is not significantly inhibited. Third, the comprehensive functions of the soil. All microplastic treatments reduce the ecological function of the soil. At the same concentration, the negative impact of smaller particles is greater. Soil respiration is the most crucial indicator for evaluation the soil function. The concentration of microplastics is the primary factor affecting the soil properties, and the influence of particle size is relatively weak. Only when the pollution concentration reached 6% or above, while the difference in the harm caused by particle size become prominent at the mechanism level. Microplastics have a large specific surface area and can absorb a large amount of soluble nutrients. Due to the lack of microbial carbon sources, their metabolism and enzyme activities are inhibited. Large particles can loosen the soil and enhance air circulation, stimulation microbial respiration for a short period. Both types of microplastics will disrupt the soil ion balance, leading the acidification and increased nutrient loss. Small particle size microplastics accumulate nitrogen-fixing microorganisms, resulting in an increase in urous activity, and the overall harm increased with the accumulation of concentration. Finally, PE microplastics can damage the biochemical characteristics of the soil, weaken the nutrient cycling function, and pose dual effects of both dose and particle size. This study only used a single type of soil and a single type of plastic. In the future, long-term experiments with multiple soil and multiple plastic types can be conducted. In terms of reality, agricultural residual films are the main source of microplastics. We need to do a good job in film recycling, promote biodegradable films, reduce the input of microplastics into the soil, and protect the health of farmland. That's all for my sharing. Thank you.